Hello viewers, in my last video I discussed regarding the goal-based agents in artificial intelligence. So today I'll be discussing regarding the utility-based agents in artificial intelligence, which is the fourth type of rational agent in AI. So stay tuned to this video. What is the utility-based agents in AI? This is Ranchiraj and you're streaming on the Steady Beast. So first of all, the diagram moreover looks the same for model-based agent, goal-based agent as well as same for utility-based agents. Just one state is extra which is included in this. So I'll be talking only regarding that. So you have this agent. This is the environment. Agent have senses to perceive from the environment, and you have actuators which can perform different actions for the environment. Now it has different states and how the world evolves, what my action do, all the background information which is running, and you have the utility. One extra block in goal-based agent there was a goal. Now in this there is one utility, so I'll be discussing what this utility is. And you have this sensors and what is the world like now, that you have seen from the simple reflex as well. Now what it will be like if I do action A, that is all from the model based agent, and what action should I do now. So all these things remain the same. Now one extra thing is one this block, that is the third type of state. Now this says that how happy will I be in such a state, and it derives from a utility. Now since agent receives this sense from the environment, it processes till this portion, till this state. Now after this state there is one condition action. Condition action is replaced by utility, where in goal it was goal. Goal based agents it was goal. Now in utility based agents it is utility. Now this utility will define certain kinds of like possible solutions or estimates that how you can reach your goal. Like the reaching goal is very easy task, like you can do n number of actions and reach the goal, but that's not the case. You have to find the efficient and minimalistic solution approach to find your goal, and with minimum cost reduction and minimum time complexity. So many constraints are actually contained in this utility. So we have to achieve those maximum constraints and reach the goal. If you consider only minimum constraints, you may be like taking more time, or you may be paying more cost to reach your goal. So that actually comes in this utility. And this utility derives from a particular state. Now that state is how happy will I be in such a state. Now if agent uses one kind of utility, like for example if agent utilizes utility A, and if we reaches this goal, then it will decide whether this decision was right taken by the agent to reach the goal, or whether another option was better than this, or should I have do any other options, or like should I be doing any other alternatives to reach the goal. So this kinds of usage or utilities basically deals with this kinds of agents. So the name it is utility based agent. So it is an improvement over the goal based agent, and it is capable of finding the utility of an agent to achieve the goal. Means it will actually utilize, or it has certain kinds of actions or history knowledge base in it, which it checks whether previously whether I have done such kind of activities or actions, and out of those it will choose which one to choose the best, or which is the best minimalistic solution to approach the goal. And the utility of an agent is more if it satisfies the maximum constraints to achieve this goal. For example, if you want to reach particular destination, now let us consider this example. So this example says that you have to reach from goal A to goal B, and there are three different routes: route 1, route 2, and route 3. So in route 1 you have like you can go by walking, and in route 2 you can go by train, and in route 3 you can go by bus. Now there are two constraints in this. So those constraints are time complexity and cost complexity. Now what time complexity says is that you have to take at least 45 minutes, and cost complexity is that the cost you can reach to that goal is by estimated by an amount of $50. Now these are the various utilities which are being loaded into this utility based station, this background information. So these are basically the background information which are being loaded in this utility. So first, if you go by walking, like if you go by walking, you hardly pay, or if you don't pay any money, like it will take like only one constant is satisfied in this. So the cost complexity will not be there, only the time complexity will be there in this case. So since you have to reach your destination by 45 minutes, this constraint will be like violated. So it may be like you may be reaching 45 minutes, not 45 minutes, 1 hour or 1 hour 30 minutes, maybe 1 hour 45 minutes, 2 hours. So it could be more than this. So you just cannot consider only one constraint for reaching your destination. Although it can be achieved, but that's not the minimalistic solution, or the not possible efficient solution for reaching your goal. Means you are not utilizing all your constraints. So that's where the utility based agent comes into picture. So since you have given two different constraints, you have to utilize it both efficiently. Now if you go by train, metro, then it could be like you may be reaching your destination for 30 minutes, by 30 minutes. So it's like moreover like acceptable. And if you go by bus, then it would be like it would be taking less than 45 minutes. Moreover, if it comes to 30 minutes, then that's fine. So out of this, agent will select which is the best option, or which is the best route to reach from goal A to B, the source to destination B, and it will utilize all of these constraints which it has. If it sees that any one constraint is not being utilized, or any one constraint is being violated, it will simply reject it and will jump onto the other two possible solutions to reach its goal. So this was a practical example of utility based agents. Since utility based is basically used like for self-driving cars in Google cars, where you have driverless vehicles and all. So in that, if a passenger wants to reach from A to B or some other place to one destination, then these are the basic classical or traditional way to implement those kind of situations. And so, well, this is all about the utility based agents in AI. So hope you enjoyed this video. From this video helpful, please hit the like button, and if you haven't subscribed to my channel, please subscribe. Thanks for watching this video.